talk about some basic counting principles and eventually permutations and combinations, but we're going to start off with just some basic counting principles. So in example 1, we're going to determine in how many ways a computer can randomly generate two integers from 1 to 12 whose sum is 6. So we want to randomly generate two numbers that will add together to equal 6. So let's just start off. If we got 1 as our first number, the second number would have to be 5 to total together to get 6. If our second number was 2, then, not our second number, sorry, if our first number was 2, then the second number would have to be 4 in order for those to add together to get 6. If our first number was 3, then the second number would also have to be 3 in order for these to add together to get 6. If the first number was 4, the second number would have to be 2 in order for them to add together to get 6. And if the first number was 1, the second number, I'm getting ahead of myself. If the first number was 5, the second number would have to be 1 in order for these to add together to get 6. Now, neither one of these numbers can be 6. Like I can't say if the first number is 6, then the second number would be what in order for these to add to give you 6, because nothing adds to give you 6 if the digits are between 1 and 12. So I can't use 6 as one of my randomly selected integers. So 1 plus 5 is 6, 2 plus 4 is 6, 3 plus 3, 4 plus 2, and 5 plus 1. So these are all of the different combinations or the different ways that we could have these combinations or randomly generated integers add up to give us 6. So there are 5 different ways that that event could occur. 5 different ways. Okay, so let's try a different situation. Determine in how many ways a computer can randomly generate two distinct, that means two different integers from 1 to 12 whose sum is 10. So we're going to do the same situation here, but we want them to total up to add to be 10 instead of to total up to be 6. So I'm going to do the same thing, but I'm going to write it out a little differently. My first set of numbers can be anything from 1 to 9. Like right here, my first set of numbers could be 1 to 5, as long as the number is less than 6. So I could have anything from 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now my second number has to add with this first number to equal 10. So this number would have to be 9, this would have to be 8, and 7, and 6, and 5, and 4, and 3, and 2, and 1. So that these would total up to equal 10, 10, 10, 10, 10, 10, 10, 10, and 10. But remember, this right here said two different integers. So out of these different combinations or different setups or situations here, I'm going to have to eliminate this right here, because this 5 and this 5, these are not two distinct or two different integers. They are actually the same number, so I cannot use that one based on this information given to me in my problem. So there's only 8 different ways that that event could occur. Oops, that's supposed to be a Y. I'm really messing up today. Alright, so let's try this again. Alright, we'll make that be a big Y. Let's try that again. 8 ways. Hopefully I'm getting a routine and clean things up a little bit. I've messed up several times so far here. Alright, now remember, if they hadn't said distinct or different integers, then you would have not had to eliminate the two 5s. It's just this part right here is the only thing that made us have to eliminate those two 5s there. Alrighty, for the next two examples, instead of really reading through and talking about what's in the box here, I think the easiest thing to do is just dive on into these examples. So let's see what's happening with example 3. A combination lock will open when the right choice of 3 numbers from 1 to 30 inclusive, that means we're going to include 1 and include 30, is selected. How many different lock combinations are possible? So what I'm going to do here is I'm going to put 3 blanks to represent the 3 different numbers for my combination lock. Now I have 30 different numbers that I can choose from for my combinations. Now this problem doesn't say anything about not being able to repeat the numbers. Like your combination for your lock could be 888 or 27, 27, 27. There's nothing that says that you can't repeat. So I have 30 numbers to choose from for the first number in my combination. I have 30 numbers to choose from for the second number and 30 for the third number. And all I do here is I multiply these together. So 30 times 30 times 30 is 27,000. So there's 27,000 combinations for that lock. Let's try number 4. In a certain state, each automobile license plate consists of 2 letters followed by a 4-digit number. I'm going to do the same thing here. Here are 2 blanks for my letters. Then I have a 4-digit number. 1, 2, 3, 4. Here's the blanks for my numbers. How many distinct? Now distinct just means different license plate numbers. How many distinct license plate numbers can be formed? That just means that you can't be driving around with the same license plate number that I'm driving around with. But it does not mean that you can't have the same letter or you can't have the same number. So don't get confused with that. I mean, you can have 2 of the same numbers or 2 of the same letters. It's just that 2 people on the road can't have the same license plate. So how many letters are in the alphabet? There's 26 letters. Now, it doesn't say that I can't have the same letter, so we're going to do 26 letters times 26 letters. And numbers. Now, 0 is a number, and it doesn't say anything about not being able to use 0. So if you use 0 through, now you're not going to use 10 here. You would use a single digit number, so 0 through 9 is actually 10 numbers to choose from, 0 through 9. So you have 10 digits to choose from there, 10, 10, and 10. So if you would multiply all those together, that is actually 6,760,000 different combinations of license plates. I don't know if y'all have noticed in Texas, we've actually added a digit on the license plates. I guess they've run out and they've started adding either an extra number or an extra letter. Okay, now we're going to talk about permutations. What you need to know about permutation is that order is very important. So I'm going to come up here around where it says permutation in the box, and let's put order is important. It's very important that you know that the order is important for a permutation. That means that everything has a very specific place. Because we're going to talk about combinations in a few minutes, and the order is not important for a combination. So for a permutation, everything has a place. So let's look at number 5. In how many ways can 8 children line up in a row? And I'm going to show you a couple of different ways of doing some of these permutations. But one of the ways that you can do this is if you're going to line 8 kids up in a row, you can put 8 blanks, 1, 2, 3, 4, 5, 6, 7, 8, and we can do it this way. If we have 8 kids, then I have 8 kids to put in the first spot. Well, once I put a kid in this spot, then this spot is taken, so I only have 7 kids to put in the second spot. Now these 2 are in their place, so then I only have 6 kids left to go in that spot. And then 5, and then 4, and then 3, and then 2, and then 1. And if I multiply all these together, then that is our factorial. So I just multiply 8 factorial. Now, if you will follow along with me here, it's just going to help you understand the next 2 problems. What we just did is if we had 8 kids, but each kid actually had a place. We're going to have some problems in a minute where what if we don't have places for all 8 kids? What if we're only placing, say, 4 or 5 of them? We had 8 kids, and we took them, they were taken 8 at a time. Okay, 8 kids taken 8 at a time. Now here's how you write that as a permutation. What that will look like is 8 kids taken 8 at a time. Now if you do your 8 factorial button, then you're going to get 4,320. So there's 4,320 different ways that can happen. And I'm going to show you how you do the 8p8 in the calculator. I think I'm kind of getting ahead of myself with the little box here. Let's see. Yeah, here's where it comes up. 8p8. I'm going to go ahead and show you now since I wrote it down though. 8p8, 8 kids taken 8 at a time, which will be the same as our 8 factorial. So I'm going to pull the calculator up. Now if we did 8 factorial, we would get 8 math, go over to probability, number 4, 8 factorial, 4,320. Or if we did 8 kids, go to math, go to probability again. Now look, notice here's a permutation with the P and here's a combination with the C. It's important that you know which one you're doing. We're going to do a P for permutation because the order is important. So 8 kids taken 8 at a time was 40,320. So back over here, doesn't matter which way we looked at this problem, we got the same answer both times. So let's flip over to the next group. I just kind of talked about permutation again. Order is important. Order is important. And this little NPR, n elements taken r at a time. This is your number of elements taken this many at a time. So let's look at number 6a. A coin club has 5 members. In how many ways can a president and vice president be selected from its members? Well, you can do this 2 ways. You can do the blanks. We have 2 positions to fill. We have a president and we have a vice president. We have 5 members to choose from. We have 5 people to choose from for president. 5 people. Once somebody gets chosen president, that only leaves 4 people to choose from for vice president. So we have 4 people to choose from for vice president. So 5 times 4 is 20. And I did blanks because everybody has a specific position. Now I could do that with our notation here. I have 5 members. How many positions do I have? I have a president and a vice president. So 5 members chosen 2 at a time. I'm going to put a little or because there's 2 different ways you can do it. 5 members taken 2 at a time because we had 2 positions to fill. So 5p2 would come out to be 20 also. And let's try one more of these. 8 horses running a race, and how many different ways can these horses come in first, second, and third? Well, if we do our blanks, we have a first, a second, and a third position. We have 8 horses that can come in first. Once somebody comes in first, we have 7 that can come in second. And once somebody comes in second, then we have 6 that can come in third. So if I multiply all those together, that is 336. Or I can say that I had 8 horses and I had 3 positions that I could have placed in first, second, or third. So 8 horses taken 3 at a time. And again, I'm going to come put up here in a little different color for both of these. Order, important. Order, important. The hardest thing about some of these is figuring out, is the order important? Is it important if you get president or vice president? You bet. Is it important if you come in first, second, or third place? Of course it is. What doesn't matter is if you're on a group or a committee. That's when order is not important, and that's what's going to be coming up here in a few minutes. All right, before we talk about combinations, we're going to do distinguishable permutations. And this is kind of a strange problem, but it's easy to do if you will. We don't really need to follow along or read this situation in the box again. It's just easier to do the problem down here. Find the number of distinguishable permutations. And again, the distinguishable means just different, for different letters, different permutations of this group of letters. How many different, not different, but how many total letters do you have here? We have 9 letters total. So what we do for the numerator is you do 9 factorial in the numerator. And then what we do in the denominator is we are going to put each letter factorial in the denominator. So let's look at our A's. We have 2 A's. So we're going to do 2 factorial. Okay, and that's for our A's. Count up your E's. You have 3 E's. So 3 factorial. That's our E's. We have 1 J. So 1 factorial. That's my J. We've got 2 P's. 2 factorial. That's my P's. And I have 1 R, so 1 factorial is your R. And all you need to do is just calculate that. And some of y'all like to put this in your calculator all at once, and that's fine, but you have to remember, my pen's going nuts, I'm sorry, that you need to put all that in parentheses. And so calculate all that, and you will get 15,120. Alrighty, so let's finish up with some combinations. Alright, when we talked about permutation and we said that order is important, for a combination, the order is not important. Not important at all. And so since the order is not important, you cannot draw blanks. Okay, I'm going to just write on here, you cannot draw blanks. Okay, by drawing blanks, you are putting everything in a certain place, in a certain position. All right, so you can't draw blanks for a combination. For number 8, in how many different ways can 2 letters be chosen from the letters A, B, C, D, E, F, and G? The order of the letters is not important. So you are told that the order is not important. I just want 2 letters, random. I don't care what order you choose them in. So how many letters is that total? There are 7 letters total. And it's a C now instead of a P because the order is not important. And I'm going to choose 2 of them. So we have 7 letters taken 2 at a time. And before I even calculate it, I'm going to put a little star here. Order is not important. Okay, so let's go back to the calculator. And let's type in 7 math. Go over to probability. This time we want combination right here, which is number 3. And we're going to take 2 of them. And it's 21. So 21. Now if you follow the formula here, then you would get 7 factorial over 5 factorial and 2 factorial if you filled out the formula. But if you will want to use the calculator, that is okay too. Just make sure that you know how to. All right, last two. Let's finish up here. For a certain experiment, 4 students are randomly selected from a class of 20. How many different groups, right, there's your keyword there, groups. For a group, order is not important. Order not important for a group. How many different groups of 4 students are possible? You have 20 students, and it's a combination because order is not important, and you're going to choose 4 of them. So following our formula, we would have 20 factorial over 16. The 16 comes from 20 minus 4 factorial and then 4 factorial. Or you can do 20C4 in your calculator, 4845. So 4,845 different combinations there. And for the last one, you are forming a 10-person committee. Again, on a committee, it's not like you have a position, vice president, president, chairman, secretary. Those people have a position. But for a committee, order is not important. So I'm going to come down here where I see the word committee. Order not important. Important. Okay. You're forming a 10-person committee from 9 women and 12 men. The committee must consist of 5 women and 5 men. How many different 10-member committees are possible? Okay, so from 9 women, you're going to choose 5. From 12 men, you're going to choose 5. We're going to choose 5 women, and we're going to choose 5 men. Choose 5 women and 5 men. And since it's and, we will multiply them together. This is our choosing our women. This is our choosing our men. And you will figure out what this is, figure out what this is, multiply them together. And it's 99,792 different combinations there. And that takes care of combinations and permutations and counting principles. Just make sure you remember where the order is important and where the order is not important.